Okay, so let me just go to my second part, right? So in this case, we are going to be talking about the internet access to VPC by the internet gateway, the NAT gateway, and the Bastion hosts. Okay, so let's see if again, if you're new to it or if you are you have some previous understanding, it will still make sense to you. So this is where we left off in the first part. So next what we do is now this is imagine we have internet here and then public internet, and then we have outside of the empire, what do we have, right? So anyone who wanted to reach through the internet into from the internet, right, into this public subnet and wanted to reach out the application, right, they can do that, right? So the same goes from the main castle gate into the public chamber, so to the public minister, that's possible, they can happen directly. But if you wanted to reach out to the private subnet, you cannot do that, right? And here, and then if you wanted to reach out this other private again, the private chamber here in our castle, no, that's not possible. And then if you wanted to, so if that's not possible to reach out here, so what we can do, so we are adding another, I would say, instance or EC2 that's configured as a Bastion host. And again, the Bastion host have the difference is has different security configuration, right? So because if the traffic is coming from the public internet and wanted to reach out to the web server, it has to become secure, and that's why it has to go through the Bastion host and then into our web server. So, and then I have another thing, I would say Bastion host here in our castle analogy as well. So it goes from the internet into the Bastion host and then it goes into our web server. So this is how it's going to work. And then this is only for incoming traffic. So just remember, so if any internet, any traffic from the internet wanted to reach out to the web server, it has to go through the Bastion host into the web server. So that's for incoming traffic only. And then from the web server, so the web server can communicate with the database back and forth, right? So that's an easy thing. And again, about how these two communicate with each other, that part might be a bit more complex and complicated, which we are not going to go into depth at the moment. So just imagine these two can communicate with each other. So now let's see what else do we have, right? So in here, I just added another EC2 instance, and then our castle analogy, we can call it a treasurer, right? So a treasurer is just someone, again, in the private chamber that cannot be reached out from the outside. So it's just the same thing that I'm explaining here. I'm explaining it through some really simple terms, right? So again, the treasurer can be, so the secret wizard and the treasurer, they can talk to each other, right? But they cannot talk directly to the internet. And that's why we had the Bastion host coming through the secret wizard, and secret wizard is then talking to the treasurer, right? Back and forth. So that's what is happening. And now what happens if this database wanted to talk directly to the internet? Can it do that? No, it cannot do that. In the same way, can the treasurer talk to the outside world directly? No, it cannot do that. So what do we have now is that, again, so we have this web server. Can it talk to the internet directly? No. Can our secret wizard talk to the outside world directly? No, they cannot do that. So what are we going to have now is adding something called a NAT gateway or a NAT instance, right? So the difference between a NAT gateway and a NAT instance is NAT instance, you can configure that and you manage the NAT instance, but a NAT gateway is managed by AWS, right? So it's an EC2 instance, again, that's being configured to be more secure. And the main purpose for that is that anything that wanted to reach out to the internet, so NAT is for outgoing traffic only. So the database or the web server that wanted to reach out to the internet, how does it do it? It goes through the NAT gateway or through the NAT instance and then out into the internet, right? So, and then also if the database wanted to reach out directly through the NAT gateway and then through the internet gateway and out into the internet. In the same way, the Bastion host can also directly reach out to the database and then it reach out Yeah, so it reaches from the internet into the Bastion host into the database. So before I said it's coming from the internet into the Bastion host, into the web server, into the database, right? So that was kind of like 3 steps. But what about if I wanted to access database directly through the Bastion host, not through the web server? Can I do that? Yes, you can use the Bastion host to SSH into, or SSH is another way of saying reaching out or accessing this database. So from the internet into the Bastion host into the database, or from the internet into the Bastion host into the web server. For incoming traffic, for outgoing traffic, database talk to the NAT gateway or NAT instance in the public subnet, and then through the internet gateway outside through the internet. Same way, web server talk to the NAT gateway or NAT instance, and then through the internet gateway, and then out into the internet. So that's what it is. And then if we just put something really simple here. So NAT gateway is for outgoing traffic. And if you wanted to remember it, in simple words, you can say just imagine in a NAT start with an N. So it's kind of knocking out someone out of the door. So like anything that you wanted to get out from those private chambers into the internet, just knocking it out from the AWS network entirely, then that's where you use the NAT gateway or NAT instance. But if anything wanted to enter, that's where you use the Bastion host. But there is one little thing. So the NAT instance, not the NAT gateway, only the NAT instance can be configured to act as a Bastion host. So the incoming traffic and outgoing traffic can go through the NAT instance, but not NAT gateway. So only NAT instance can act as a Bastion host. On the other hand, the Bastion host can only act for incoming traffic. So that's my understanding up to this point, right? So I have been learning it through different Udemy courses, WizLab, and some other online platforms, that this is how a NAT gateway, NAT instance, and Bastion host work, right? So my understanding is up to this point, there might be different purposes for these services, but up to this point, I think so I have what I have learned so far. So I'm sharing what I have learned from those courses so far. Okay, so let's see what we have next. Okay, I think so I'm almost done for my second part, which is 2.1. And now I will be going into 2.2. And then in this one, we'll be talking about the VPC subnets, right? VPC, yeah, and then subnets and CIDR ranges, right? Okay, so let's see what we have. I think so, did I make a mistake saying VPC and subnets? What I meant was VPC subnets and CIDR ranges. But anyways, I might have made a small mistake in here. But the main thing, we will be covering CIDR ranges in this one. And let's see what is a CIDR range, right? Okay, so let's just have a VPC in here. And then in this VPC, we're adding a public subnet, a private subnet, and then adding some EC2 instances into those, let's say subnets, right? So then we're giving a number. Just imagine this is a number that we're giving it to this VPC. And then in layman's term, or in, I would say in the ways that we can understand, let's imagine this is a phone number for your house. So a VPC, this is your house, and this is the general phone number for your house. Or if you think this is a building, right? So this is kind of like the number for this building, for this entire building. And then you have different floors. And then within those floors, you have different, I would say, units or apartments. And so those are those different units in apartment. So a building can have one general phone number, and then different, I would say, floors can have different numbers. And then certain units within those floors can have different numbers. Or I think so this building analogy might not be helpful. We can think of that as an organization, right? So you have your company, right? So you have a general company number, And then you have different departments. So the public department can be that communication department that can communicate with outside world. And then you have the private department where people don't talk to the outside world. So then they have different numbers. So I'm just giving them some numbers. So you have a general company number, then you have specific department number, and then within those departments, you have specific offices, right? And then those offices will have their own phone numbers, right? So I hope it kind of makes sense to you, the general building number. But now, how did we come up with this specific number, right? So let me just go a little bit. So if you have, I would say an IP range. So this is an IP range or CIDR range, right? So it's 10.10.00/16. So this is an IP range. And then this thing in blue is actually the prefix or subnet mask, right? So how do we come up, or what do these numbers actually mean? So if everything is 0, that means it's out to the internet. And all those digits can change, right? And by change means these digits, you can put any number in here, and that might correspond to a certain IP for a certain device out there in the internet, and that's how you want to reach out to it. So for example, if I'm putting, this database wanted to reach to the internet here, right? So this means, so I wouldn't call the database because database cannot reach out to the internet directly. So I will say if this application in here, in the public subnet, want to reach out to the internet, then the IP range that it's trying to access will be this thing. And then from there, it will be more specifically routed to a specific device that has a specific IP, right? Okay, and then so if it's a /8, this means only the last 3 digits can change. And then if it's /16, only the last 2 digits can change. And if it's a /24, only the 1 digit can change. If it's /32, no digit can change. It means it's only a single IP. Again, how we come up with those numbers, I will have a separate video on CIDR ranges just to explain how we come up with those numbers. But for now, if you're using these numbers, you can understand to a certain extent, what do they stand for? And there's a simple formula for that. So 2 to the power 32 minus the prefix, right? So if the prefix in this specific example is 16, and then 2 to the power 16 is almost over 65,000 different IP ranges. So if we give this specific /16 range to our VPC, this means up to 65,000, over 65,000 devices in this VPC can have IP ranges. So you can go with up to over 65,000 VPs in this specific VPC, right? And then you wanted to further divide that into parts, right? So the /16, and you can see for a subnet is /24. So always and always, the bigger those numbers, the more specific they are. The smaller those numbers, the wider they are. So they cover much more bigger range as compared to this one. So for example, imagine if we, instead of 32, we wanted to put 24, then that will be a smaller number. So 2 raised to the power a smaller number, then this IP range will be much smaller, which means this is a smaller prefix, a smaller range as compared to a /16, right? So /16 is more, I would say, wider range, and then a /24 is more specific, hence more smaller range. So let's see what we have. So I'm just doing this thing to make it a bit more easier. For example, if it's a /32, 2 to the power 1, like putting this in thing, this prefix into this formula, this is how we come up. For example, if it's /26, it allows only for 64 IPs because 2 to the power 6 is 64. If we have a /, I would say, 24. Then there will be a 256 IPs because 2 to the power 8 is 256. So on a subnet level, right, and this specific subnet has a /24 IP range. This means there can be up to 256 IPs. So up to 256 IP ranges can be accommodated in this specific public subnet, right? And then the same goes for this one. So within, for a VPC, the last /16 means the last three digits can change. So for example, if I'm putting this one into the subnet, I'm giving a part of this IP range to the subnet, then I can only change the last 2 digits, and see how I'm changing this one. So for this one, I'm changing this, I'm not changing anything, so I'm just putting the 0, and then for this one, I'm changing 1, right? If I'm going to add another subnet, I can put 2, and here I can put 3, but I cannot touch these first 2 digits, right? So these first 2 digits cannot be touched, no matter, so 10.0. This cannot be changed, but the last 2 coming from this /16 can be changed. Now further, if you wanted to give a specific IP to this EC2 instance, right, inside my public subnet, then what can happen, only and only the last digit can change, right? So for example, if there is an EC2 instance with 10.0.0.1, the other one can be the last digit, and here it can be 0.2, 3.4 and further on, right? And then also, if you look into this one, I'm not being able to change 10.0.1, and then this thing can change like 1.1, it can become 1.2, 1.3, but whatever these digits are in the subnet, they take the same one, but only the last digit changes. In this one too, they take the entire thing, kind of they inherit the entire thing from their subnets, but only the last digit can change, right? On a VPC level, the subnet inherits everything, but only the last 2 digits can change. On a subnet level, if an EC2 is getting an IP, then everything can change, inherit everything from the subnet, and only the last digit can change. So I hope it's kind of making sense. Let's see what we have. So I got rid of those other information. So I can say, yeah, again, a CIDR range can be a phone number that you can give to your different things. You have a company, there is a main general line you can reach out to a specific department. And within those departments, you have certain offices that you can reach out to. So this is how it is, right? So I'm just adding a few more, I would say, subnets, some EC2 instances, and then let's see if we add more EC2 instances in there, giving some more IP to them. So now see how it makes sense, right? So again, this EC2, and this EC2 instance, they are all inheriting, I would say, the first, how many digits? So 1, 2, and then 3, right? So that all the 3 digits they're inheriting from the subnets, and only thing can change is the last digit, right? So if you can see that, this the last digit can change. So 0.1, 0.2, 0.3, and for this one the same goes, only they're taking everything. So it has like 10.0.1, and this one 10.0.1. So this thing is inherited from their subnet, and the only thing can change is 0.1 then, right? And then also the same goes from this 1.1, 1.2, 1.3. And then for this one, since the subnet has a 10.0.2, inheriting the first, I would say 1, 2, and 3 digits from the subnet, and then only this one can change. Okay, so this is 2.1, 2.2, and then we have the last one as 2.3. I really hope it kind of makes sense. But now we just drop a few phone numbers or CIDR ranges for our VPC, right? So here you go, we're just giving some numbers in there, but I'm hoping that it actually did make sense. So I think so we did cover the CIDR ranges for this one. So that's all for this part.